Okay, so here's problem number 5, and I don't think we've really done these yet, but it's actually really easy. I know you've done area above and below, and area between a curve and the x-axis is known as distance traveled, right? Maybe total, maybe net. So anyway, this is a graph of velocity, and it's you know, a turtle's moving to the left and to the right, and something to remember is that when velocity is positive, the object always moves to the right, and when velocity is negative or below the x-axis, it means that the object has moved to the left, and it's going to change direction at the zeros of the velocity graph. So maybe, you know, I left my house at time equals 0 and I'm driving to school because I'm coming back, right? And then I said, oh no, I forgot my lesson plan. So I turn around, I start headed back home, and maybe I stop for a while, and then I say I'm too tired to go back to work, and then I try again, and I don't know, other things going on. And then anyway, I head on back to my house, and then I say, no, you know, here it is in my purse, I'm going to head back to school, and then off I go again. Okay, so I went from, you know, going to the school, turning around, going back home, and then going back to school. So I'm changing direction at 3 and about 7.5 here, so just so you know that. So this turtle's moving back and forth, and at time equals to 0, he's already 1 foot to the right of this mailbox. Okay, so at time equals to 0, when they started monitoring this turtle, he was already a foot to the right of the mailbox. So you got to keep that in mind. So this is A. Where is the turtle in relation to the mailbox at t equals to 4 minutes? Well, it's easy. I already know he's 1 foot to the right, and now all I have to do is add up these areas, right? So here's an area of 1 times 2, or 2. The area of this triangle is 1/2 base, so 1/2 of 2 is 1, times the height is 2, so this whole area of this whole triangle here is 2. Now the area of this little triangle is below, right, so we're going to subtract it out, and it's 1/2 times 1 times 1, so it looks like negative 1/2, right? Think of it, or half below. So what I have is, at 3, he's the 1 foot to the right plus 4 feet, so he's already 5 feet to the right of the mailbox there, and then he turns around and starts heading the other direction, and so we subtract that out. So anyway, we would say that he's 4.5 feet to the right. Why? Because the area above is greater than the area below. Okay, so he's still to the right. If the area below would be greater to the right, then we'd say he's to the left. Okay, where is the turtle in relation to the mailbox at t equals to 5 minutes? Again, he's already 1 foot to the right of the mailbox at t is equal to 0, so I don't want to forget about that 1 foot. But anyway, we have 4 feet here, and now, you know, if I compute this area below, this is 1/2 times 2 times 2 is 2, right? So these two areas here are the same, they cancel each other out. So 2 feet plus the 1 foot is equal to 3 feet, and he's still to the right of the mailbox because there's only area above here. Make sense? Now we have a ladder problem. Okay, so we have a 25-foot ladder sliding down a wall. So I'm just making my triangle, right? I know it's going to be a right triangle. Here's my ladder. It's 25 feet long, and that length is, that length is not going to change. Okay. And what I know is that the ladder is sliding the wall so that the base is moving along the ground at 3 feet per hour. So I know that dx dt is equal to 3. Okay, and it's positive 3 because the base isn't going in. It would be like the ladder is sliding up the wall or something, I guess. But if we were pushing the bottom in toward the wall, that would be a negative. But it's not. This ladder is sliding down the wall, and so this rate here for x has to be in this direction. Okay. When the ladder is 10 feet from the wall, how fast is the top of the ladder moving along the wall? Okay, so I'm trying to find dy dt, right, when y is equal to 10. So I know y is equal to 10. I know this is 25, and by Pythagorean theorem I can find the other missing side, right? 25 squared minus 10 squared. So it's what, 525? And that's not a perfect square, so I'm going to let x equal root 525. I'm just going to leave it like that, and you should too. Okay, so because it's a right triangle, we're going to use the formula x squared plus y squared is equal to 25 squared. This length will never change, so it's a constant. And now if we differentiate both sides, we're going to have 2x prime plus 2y prime is equal to 0, right? And that's 2 times root 525 times x prime is 3 plus 2 times, when y is 10, times y prime is equal to 0. So remember, never plug anything in until after you take the derivative, except for cones, and the only reason why you're doing that in cones is to get rid of a variable. With ladders, we don't need to do that. Okay, so this is pretty ugly, and the idea is that we want to isolate y prime, right? So y prime would equal to negative 6 root 525, I'm writing with a purple pen, over 2 times 10 is 20, right? And if I compute that up, looks like I'm going to get negative 6.874, and that would be feet per hour. And that's it. So I guess the answer would be B. For that one, it would be B. Alright, number 7. So let me just fix this here because this is a little bit weird the way I've got this thing set up. So we want to use the table to the right to answer the problems. If f is continuous and differentiable, meaning that it's somehow it's some nice smooth curve without any, you know, points or cusps or corners or breaks or anything like that. There are no holes because it's differentiable, meaning you can take the derivative at every point over its domain. Then approximate f prime of 3. Okay, so I don't know what the function is, but if I have a table of values, I know that I can use what we've already learned in chapter 3 to kind of give myself a good approximation, because remember, that's what it says, approximate f prime of 3. So I want the derivative of this function right at this point when x is equal to 3. So that's f of 4 minus f of 2. F of 4, remember this is in the middle, so you just go a little bit to the left, a little bit to the right. F of 4 minus f of 2 over 4 minus 2. Well, f of 4 is 5. F of 2 is 4. 4 minus 2 is 2. So the answer is 1/2. Okay. They just put the table vertical rather than horizontal, but I think if this were, you know, like this, you would have seen it better. Okay, so here's we want the derivative. We want to approximate it at x is equal to 3. So you just, you know, make sure this is centered, and you know, 4 minus 2, f of 4 minus f of 2 over 4 minus 2 would work perfect. Now number 8's a tough one, so I'm going to do that. It's a tough one because it's a nightmare of a function to put in the calculator, if I recall. I don't know, let's see, let's try and do it right now. So we're given the derivative. So remember, this is the derivative of the function that we're given over the interval 0.7. So they couldn't have made it any more hellacious. At what value of x is the tangent line to f horizontal? So I want to know, when does this derivative equal to 0? Okay, so I'm going to cut this video off here, and I'm going to continue on with problem number 8 in the next video.